Good morning, ladies and gentlemen. Good morning, respected juries. Myself, 𝗍𝗲𝗃𝗏, Tata Motors, Pune. Next 15 minutes, I'm going through the digital innovation in gearbox assembly line, which are done practically. We will going to show here. Tata Motors, CV Pune. Our project is operational excellence in the lean manufacturing digital gearbox assembly. Sponsor is our planted Mr. 𝗍𝗲𝗃𝗏𝗃, sir. Our mentor is Prasad Pulke, is our factory head, and myself, 𝗍𝗲𝗃𝗏𝗃. Tata Motors, you know the Tata Motors manufacturing, there are two, one is the passenger, one is the commercial vehicle. We are in the commercial vehicle business unit, where we are manufacturing at Pune plant is 4-ton to 19-ton vehicles. These are the variants we are manufacturing at Pune plant. Here, I am from the gearbox assembly line. For the gearboxes, we are manufacturing for this various commercial vehicles. In that, there are this marked G400 and G550 gearbox assembly. The project is, depending upon, it covers 80% of volume. The existing manufacturing process is the manual gearbox before the start of the project. And this is one of the critical process demanding precision and consistency. And continuously operation relied on heavily on the manual data entry and the human judgments. Challenges manual data because it takes time to record on the manual history cards. Then lack of centralized data for the analysis. Then high dependency on the human intervention. And it is the industry relevance is there because the integration of smart technology and automation, real-time data analysis for operational optimization, and improved traceability and quality control in manufacturing. Actually, problem is that the conventional assembly of gearbox assembly and sub-assembly line relied heavily on the manual operations and lacked in a centralized system for data management, resulting in insufficient record-keeping processes, increased chances of human error in operations, difficulties in ensuring the traceability and quality control, monitoring the losses during the operations. Major challenges are manual dependency, data gaps for the incomplete and inaccurate data, and then quality assurance, lack of effectiveness, mechanism to prevent the defects in the production processes. The primary object of this project is to initiate was transfer the gearbox assembly process by integrating lean manufacturing principles with the advanced digital technology. And the project aimed to address the existing inefficiencies and strengthen the process stability and create the transparent data-driven environment that enables the faster and more accurate decision making. And we have taken some KPIs, start of the project, cycle reduction by 15%, station connectivity by 100%, OLE 90%, existing is 74%, then build a product to data-driven shop floor with 100% on HMI, because the operators working are semi-skilled, and achieve sustainable operational excellence, DRR, direct run rate is 95%. Actually, it is the corporate level, it is the led digital journey in 6 KTs. What is KT? KT is the key themes and two key enablers. On these 6 key themes and 2 enablers, this entire project is connected to this all cycle. The tools which are used are automated measurement tools, direct, that is smart tools. Then quality and safety POCI, we called as the L3 control is the highest level of the control on the shop floor and for the quality, and S3 is the safety, highest level of control on the safety. IoT sensors, digital history card instead of the we are started. Then PLC and HMI integration is the major we taken the tool and data analysis dashboards. This is the architecture for RFID tags implementation. Suppose this is the one of the line. In gearbox assembly, there are three main parts. One is the main shaft assembly, second is counter shaft, third is the rear half and front half. Three sub-assemblies come together and start the assembly. So we started the actions from the sub-assemblies. So this is the one of sub-assembly, the architect showing that the station one, the pallet which is we have put the RFID tag and RFID reader is there. So the data whatever we are measuring on that station, it is going to the RFID reader to the SBC board and then to the PLC. This is, and also it is moving from one station to the next station. Same way, this is the one of the line which the data is moving. Station 1 to station end of this line. The whatever the start from the start one station is the model selection data. Then whatever the quality parameters are on that station. For example, groove, circular groove measurement value and axial float value. These are the whatever the we are reading taken that is directly going through the pallet RFID tag to RFID reader, and it is moving through the station by stations, and the end of the line, it is collected on the digital history card. This is the second line where actual readings, actual photos are there. This is the rear half assembly. After completion of first line, second line, third line, the entire data from pallet RFID tag to the PLC, then it is go to the main PC. In between the stations, whatever the parameters are there, that parameters are connected to this RFID, and also from the communication pallet to PLC to HMI connections there for the operator introversion, and also the indications for compliance, and it goes to the SQL server and generates the digital history card on the PC. This is what actually we have done on the lines. These are the tags, these are the pallets. This is one of the example. If you see one of the main shaft assembly, the operator, there is a chance of operator missing the bearing putting before entering gear on that. There is a chance of missing this bearing, needle bearing. We have provided the laser sensors and will ensure that pallet and the station is interlocked. Actually, this is video, it is PDF, it is not running, but how we are trying to show here, how the cycle is interlocked and also how the operator came to know the before authorization or before end of the cycle. Same way in another, this is also a precision component, gear synchro ring, thickness is very less, so this part chance of missing is there. So the laser sensor is fitted and it is interlocked with the sensors to the cycle. This is the one where it is the important parameter in the main shaft where the float is checking. Initially it is manually. Now the direct contact type digital dials are used to check the float and ensuring that whatever the quality parameters are mentioned on the system, that will be maintained. This is also one of the video which is not running because this is a PDF. Same way, this is in the rear half, this is the circlip. If your circlip miss, there is a chance of disengaging the entire gearbox, though this circlip is also important part. And then during this assembly, we are also taking the care of pick-to-light system, kitting for each line. And for their model selection, we have provided the QR code because here the totally semi-skilled operator working. And the key outcomes are wrong part, mismatch number, inventory, on-time availability, hygiene of the components, lean layout for the material flow and housekeeping will be maintained through this activity. These are some vision system implemented on the gearbox assembly itself because these are after 3 sub-assemblies, it goes to the main assembly. During the main assembly, there is a chance of missing. So we provided these type of vision systems on line. These are the various sensors used for the digitalizations. These are for examples which you used on the line. Though the line is operated now, the operated for the semi-skilled and female employees, we are also taking the care of along with the quality for the safety also. And what I talked about that the S3 control is the highest level of control in the system. So during that, we are ensuring that two-hand safety curtains, doors, no, there is no chance to mischief happen on the lines. So that also taken the care during this digitalization. Also the new concept of 𝗍𝗏𝗏, that is digitalization 𝗍𝗏𝗏, that is also provided, and only authorized person can scan and enter in the conveyor area for the maintenance activity. As I initially talked, the main shaft assembly, then counter shaft and rear half, whatever the data is there, they are coming through the QR code up on the assemblies. Once the QR code, as per the model QR code is scanned, the entire data from the main shaft assembly line to goes to the conveyor, same way, counter shaft and rear half, so all data is come to the assembly line along with the gearbox. So the entire, whatever I shown here, number of stations, S3 controls and L3 controls, and the entire data and the quality related data will come to the direct main shaft PC along with, and that then it goes to the quality parameter analysis, Q-. After this, all we have implemented the Q-, where the critical parameters we are monitoring and the CTQ stations are identified. If you see this is the gearbox assembly line. There are 39 stations are there. Out of 30, after data enters initially to the conveyor, the entire gearbox come with the total data. For the each stations, the number of CTQ stations identified 26 and number of critical parameters 182, which are monitored for the online monitoring system is there. And we will ensuring that whatever the parameters or whatever the process are in stable conditions. Also, we tried the OLE monitoring with this all data, and itself there is we also provided the and-down on the east station, PQME, that is process, quality, material and equipment, and whatever the issues are there, the existing operator stations, there is the and-down call. Accordingly, the time starts the calculating, and it will be recorded backside. And once the entire shift completes, whatever the and-down losses is there, that automatically comes for the analysis part. During initial stage, we understood that some problems are there, and the stoppage is observing because of the unskilled operator or semi-skilled operators, and the process knowledge, less process knowledge. So we tried to alarm generation for the each process, what is going to miss or what components they are going to miss. That type of that type of alarms are generating on the HMI. And also for some initial stages, we made the step-by-step process, sequence process, to understand the entire process of that station. So it is easy to, and it helps to avoid the minor stoppages on the conveyor. And also we tried the digital JS3, what is the clit sheet. Each station has a JS3 sheet, that is we have in the JH chosen, and we incorporated in the HMI itself. That operator start the initial JS3 check sheets, then it completes and it will interlock with the first cycle. So it is compulsory to ensure that he will complete the JS3 check sheet and ensure all parameters. And whatever the real-time health monitoring of the servo motors, the servo presses are there, we use for the current and temperature, and also it is monitoring. And for the trolleys which are using for the transport, we are used as for the PM as a QR code. The QR code is used for the PM monitoring. The entire project resulted into product initially 170 per shift. It goes to 200. Bottleneck 164 seconds to 137. No touch DR are 92 to 98. OLE 78 to 94. And station connectivity 100%. Other benefits are S3 control, L3 control, CFA, that is the customer product audit points are 0. Skill manpower to semi-skilled manpower, women employee. These are the sustenance monitoring systems we have developed on the, some of the parameter on the digital, some of the parameter on, these are the, we are monitoring through the gear orange. And last, this is the last slide, second last slide. I proudly say that the Tata Motors is always leading in the CSR activity. And one is the CSR activity, is the inclusion, that is the diversity, the employees. The PWD employees are working in the shop floor. The first batch of 25 team were appointed on the stations because this digital helps to work on the station, these people without any quality lapses and safety lapses. Because these PWDs are not hearing and not talking, that the team is there. Lastly, I remember late Sri Ratan Tata sir, and one of the famous quote is, यदि आप खुद को प्रोत्साहित करना चाहते हैं, तो आप हमेशा नई चीज़ जानने के लिए उत्सुक रहिए. That's it. Thank you very much.
Good morning.
Good morning, sir.
My first question is, you have done a lot of things in digital data collection.
Right, sir.
But unless this data is used effectively, it's of no use. Okay. Now you have done a lot of things on 𝗿𝗂𝗂𝗁 also.
Right, sir.
Now, and they are trying to identify missing component, missing things. But was there a problem of missing items before you implemented 𝗍𝗂𝗂𝗂𝗁? And after implementing all this 𝗍𝗂𝗂𝗁, was there a quality improvement? And how much was the quality improved because of this?
Sir, actually, whatever the warranty issues are there, some warranty issues are there now reduced to 0. Some DRR, I talked about the DRR, direct run rate. It is capturing on the PD aggregate itself. The float, while checking the float or while checking the gearboxes, it is increased from 90% to 98%. That is 8% rise. There is a 8% lapses during the manual assembly, sir.
So you are saying initially there were 8% missing components?
Not only missing component, but some missing component and other parameters, which quality parameters are differing from the actual parameters.
So what is the quality rate now, you are saying?
98%. Sir.
First time yield.
First time rate.
Okay, thank you.
And remaining 2% is there, sir. After the gear assembly, there are some minor assemblies, though we call it as the dressing assemblies. Though there is a nut loose and bracket loose, that type of, we are also attending those two types of also, sir.
Good morning.
Good morning, sir.
This digitalization, what you have done,
Sir.
whether it is foolproof or it is in the process, halfway done.
No, it is a foolproof, sir. No, it is foolproof.
Because somewhere I could see that pick to light concept. Now, pick to light, can you just explain me how it is foolproof?
Actually, sir, pick to light is not a foolproof because it is not a L3 control, right? You are rightly talking, because the model wise there are 8 model combinations we are running the line. And the pick to light, the system is there. The only for the selection of the components for the smart kitting, the operator can identify the which model after scanning the which model. After once the scanning is on the station, the automatically the pick to light glows there component wise. So the employee working on the stations, he pick the right component and to pick keep in the trolleys. That is the smart kitting. That is the purpose of that pick to light.
But whether the right component is being placed in the right bin, that is unanswered.
It is not, now it is not, sir, but on the station itself, whenever there is a QR code for the components also, during the operations also, the sum of the components, almost 60% components are QR code, the synchro sleeve and their assembly is there, so the QR code is important. So the QR coding is helping to avoid such problems.
Thank you.
Thank you, sir.